Next, we're going to talk about sets in the context of the natural numbers. So recall from chapter 1, when we talked about the natural numbers, we defined them essentially as counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and so on ad infinitum. In set notation, we have a specific way of talking about them. There's a specific notation that's generally used. The book uses one that's slightly different. For the book, they just use a regular capital N. I think they bold it. Although technically speaking, if you want to do it properly, the notation is what's called blackboard bold for N, but it's a fancy looking N with an extra line for your purposes. Where N is equal to set of counting numbers. 1, 2, 3, 4, and so on. Where, again, as I mentioned earlier, it was bad form to write the ellipsis as I did. I should have been more careful about that. Sorry, I ran out of space. But this right here, that dot, 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 says the set goes on indefinite. Because there is no largest natural number, the set never ends. It just keeps going and going and going and going like the Energizer Bunny. So, this gives us a nice way of talking about certain kinds of sets. With this set as a basis, we can reference sets of numbers in terms of the natural numbers. So, for example, if I wanted to talk about the set 5, 6, 7, 8, 9, A equals 5, 6, 7, 8, 9. If I want to write a word description, I could say that is A is the set 5, 6, 7, 8, 9, or with this, I could say A is the set of natural numbers between 5 and 9. That is to say, A is the set of natural numbers greater than or equal to 5 and less than or equal to 9. Or I could talk about the set B of natural numbers that is greater than 99, where I could say that as B equals terrible B, even bad by my standard. The set of things greater than 99, natural numbers means counting, so go to 100, and then keep going. 2, and then so on and on and on. And we're going to talk about this in a few sections. There's something kind of cool about the natural numbers. Don't worry too much about this for now, but actually, because they're both infinite, and they're infinite in a very similar way, these actually have the same sides. And there are a whole bunch of other ways we can talk about other sets of similar size or bigger, or that sort of thing, as you can see on these tables that are now projected over my face. But before we do that, we should probably get a better idea of talking about what size actually means.